Okay, this is 2010, number 1. This is the snow on Janet's driveway problem. This is per Annette's request, so you can thank her. Okay, so for part A, the question is, how many feet of snow has accumulated by 6 a.m.? So we're going to go from 0 to 6. This will tell us how much snow fell between 0 and 6. And they told us that f of t represents the amount of snow that fell. So this is a calculator question. You're just going to do that, pop it in your calculator. You get 142.274 feet cubed. And that's part A. Okay, for part B, it's saying to find the rate of change. So the rate of change is just the derivative of the volume of snow at 8 a.m. So what would be on the driveway? So you have to consider the snow that fell minus the snow that she shoveled. She started shoveling at 6 a.m. That's equals 6. Okay, so if we need to, so we're going to need to do, sorry, that's wrong. Let me erase that. Because, let me just write this, it'll make it a lot easier. So f of t is this function. But that is, it says that this is the rate at which the snow is falling. So this is the derivative, f of t. And then g of t is the rate at, they don't tell you, oh, they do tell you. Okay, so that's the one where it's this piecewise function for either 0, 125, 108, and this is for the interval from 0 to 6. This is the interval from 6 to 7, and this is the interval from 7 to 9. Okay, so, but in any case, these are also rates, so these are also the derivatives. So it's not saying to find how much snow there was at 8 a.m. It's saying what is the rate of change, so what is the derivative at 8? That's what they're asking. So all you have to do is f of 8, that's the snow that fell, minus g of 8, that's the snow that was taken away. So for f of 8, you're just going to put 8 into this function, and when you do, you're going to get 48.417 minus, and then you need g of 8. Well, right here, if it's between 7 and 9, and 8 is between 7 and 9, the rate is 108. And when you subtract those, you get negative 59.583 feet cubed per hour. And so it's negative, and that would make sense because that's the rate of the snow, which is then slowing down at that point. Okay, now we're going to go to part C. Okay, so now is when it's starting to get a little crazy. So now they're introducing a third function, not f of t or g of t, but h of t. And you have to figure out what h of t is. And so it's saying to make a piecewise function, so that means you can do those three things like g of t. And we have to figure out what it's going to be for 0 to 6, just like the other one, from 6 to 7, and from, what was the other one? From 7 to 9, sorry. Okay, so we have to represent the total amount of snow that Janet has removed at any time t up until 9. Okay. So first of all, she has removed 0 amount of snow for 0 through 6, because the story says she doesn't start shoveling until 6. Okay, well, from 6 to 7, she removes it at a rate of 125, but what if it's not exactly 6 or 7? So I'm just going to do it down here. What goes right here, I'm going to put over here because I need some room. So we're going to have the integral that goes from 6 to t of g of t dt. So g of t dt is 125. So from 6 to t of 125 dt. So this piece here is going to go up here. Okay, and all this means is that if you want to find out how much was removed, whoops, that should be a t, from 6 to any other time before 7, it's going to be the integral of 125 dt. Okay? I know this is a little bit confusing, and I'm probably not doing a very good job at explaining this. I'll try to do a little better on the last part. Okay, the next part is going from, so I'm going to work over here, and then whatever I get, I'm going to put up here. Okay? So now we have to go from 7, but it's not from 7 to 9, it's from 7 to t up until 9. Okay, so how much will be removed? Well, it's going to be g of t dt again, but how much did she remove before that? So at h of 7, didn't she also remove all that snow? So this piece over here represents how much snow she would have removed from 7 to whenever. But you also have to consider, how did she get to 7? From 6 to 7, she had to take away snow. Okay, so h of 7, if you look on, I'm sorry, yeah, h of 7. So if what is h of 7, that's the amount of snow that's removed. So if you look at g of t, it's going to be 108. Okay, so let's rewrite this. I'm sorry. I'm kind of like looking at 3 different sheets at once. Okay, so this is just going to be from 7 to t of g of t dt plus when at 7, she had already removed 125. So to take out 125. I mean, add the 125. But what is this for g of t? Because remember, that is the rate. So we're going to have from 7 to t of 108. That's from 7 through 9. dt plus the 125. So I'm going to put that up here now. I'm going to make a little bit more room. This is extremely messy. I'm sorry. So we're going to have the integral that goes from 7 to t is going to be 108 dt plus 125, and that's going from 7 to 9. So basically, this h of t is the function you would use if, like, you wanted to check at like 6.5 hours or 8 hours, or not one of these endpoints. Okay, and then finally, so how much snow is on the driveway at 9 a.m.? That's our final goal. Get rid of all this. Okay, the amount of snow on the driveway at 9 a.m. is going to be all the snow that fell, and then minus whatever Janet shoveled. So we have this new function, h, that's this one up here that we already did. So if you can't do part C, you're not going to be able to do part D. You might get a little partial credit if you did something. Because g of t, I mean h of t is the amount that she has removed from the driveway. Okay? So if you're wondering what's the difference between h of t and g of t is the rate at which she removes it, and that was g of t, sorry. And h of t is the actual amount that she has removed. Okay? So if we want to know how much snow was in the driveway at 9 o'clock, we have to know the amount that fell, that's this f of t, minus h of 9. Okay, so that's what we need to do. Okay, so from 0 to 9 of f of t dt, you're just going to pop that in your calculator, and that gets you 367.3346. Okay, minus, well, what is h of 9? So h of 9, remember, up until 6, nothing, she didn't remove any. So we're going to start here. So from 6 to 7, so we have this minus, I'm going to put it in hard brackets, So how much was removed from 6 to 7? We're going to use this function right here, 125 dt. And then she also removed snow from 7 to 9. We're going to use this function right here, 108 dt. And we don't have to add the 125 because we're already accounting for that right over here. Okay, so now we're going to get to the annoying, really annoying part, but we'll do it. So we have 367.3346 minus. Okay, the antiderivative is going to be 125t as it goes from 6 to 7. And then we're going to have plus 108t as it goes from 7 to 9. Okay, I'm going to go to the next screen. You know what, maybe I'll go up here so just for consistency and you can see what's happening. This is extremely annoying algebra we have to do. Okay, so we still have that 367.3346 minus. Okay, so now over here we have to substitute in the 7. So we're going to get 125 times 7 minus, now you have to put the 6 in, 125, this is not cooperating, times 6. Okay, so that's the first part. And then we have to do this part over here. Okay, so now we have plus, and now we're going to do this part over here. So we're going to have 108, put in the 9, and then subtract from that the 108 times the 7. Okay, so let's start simplifying. So you get 367.3346 minus, when you work this whole thing out over here, you're going to get 125 plus 216. And when you work all that out, you're going to end up with 26.3346 feet cubed. So I did make a note on the thing that I emailed you saying that for this part, you don't have to show all of this work. I just wanted you to see where the numbers were coming from. So I know you could definitely make that a little bit shorter by doing a lot of the stuff on your calculator. Okay, that's it.